maybe before I start sharing with you a little bit background of where I come from.
Issue in Nova JC, we have the special profile of students. We take in students from L1, R5, 16 point all the way to 20 pointers. And these are students who came in, some of them are keen with learning computing. Totally, most of them without prior programming background. In fact, as you teach them, we realize that they are even struggling with their H2 mathematics. So it's quite a challenge. I cannot gauge my success based on how well the good student learn, because there's this group of students who are weaker and they're struggling and they're keen to learn. So for quite a few years, we've been always thinking on how to help the weaker students. End of last year, we kind of decided that we want to do some changes to our teaching material. We want to make teaching and learning more explicit. We have to really tell the student exactly what they are required to know. Okay, so I think today's sharing came in at a very right time, because we have sort of completed the J2 students, preparing them for their A-level prelim, not in the midst of prelim. And then the J1 has sort of more or less cover 80-90% of the J1 syllabus. Okay, so the time doesn't allow me to share too much. So basically, these are the three things that I hope to share with you this afternoon. I'm using of these unplugged activities, okay, and then also walking and talking through the program codes during lesson. Lastly is to help the student visualize the thinking. Okay, so these are three things I want to share with you this afternoon. Okay, unplugged activity. Back in 2018, that was the first time I learned from Prof. Louis and his team, okay, about unplugged activity. At that time, we learned that we unplug from all the devices from the computer. We give them physical things. We give them some activity, then let them explore and come up with a concept before we go into the computing part of it, the coding part of it. Then come in 2017, 18, no, sorry, 1920, where the COVID, that everything go online. How do you conduct unplugged activity online? So that's where we have to rethink through, and we have to adopt some online tools so that during our online lesson we can still carry on with the unplugged activities. We prepare some PowerPoint slides, and we actually attach it, and the student can download, and they play on their end. We play on our end, and then we share the screen, and that's how we go about. Okay. This year, for my J1 lesson, I have lessons that is as late as 4 to 5 p.m. in the afternoon. And if you know that students, they start from the morning, by the time they last till 2, 3 p.m., they're half dead. So to conduct lesson at 4, 5 p.m. is quite a challenge. So luckily, we have these unplugged activities to engage their interest. And in my lessons, we allow collaboration, we allow discussion, we allow talking across the class. So it can be quite noisy. The other day, my RO came to observe my lesson. I warned her, saying, my class can be quite noisy. That's how I keep them alive, at 4 or 5 p.m. And they also get a chance to visualize the process when they play the activity. I'll share with you some later on. And it deepens their learning. And these students, as they go through the experience, they remember. And when they remember, it helps them in their coding, subsequently. So I have dealt with this question about whether it's with or without the use of computer. I think now that we are back to face-to-face lesson, I have more opportunity to do physical items, moving them around. But I still use some of the online tools. Okay. The next question is that some teachers may be taken aback that you play this kind of activity. It takes up a lot of time because you need the student to explore. But then there are two kinds. One is exploratory, where you allow students to figure out the way, and that takes a bit of time. So there are also some cases where it's very prescriptive. Let me share with you. Now, for example, like teaching of bubble sort. Okay. Now there's this online tools where they just grab the weights and they put on, see which is heavier, and they bubble the heaviest one to the right, and so on and so forth. We play a game of binary search, guessing the number bigger, smaller. So it's exploratory because they come up with their own strategy. Hash table, we give them one bunch of items and ask them to keep. So some of them keep in boxes according to the number of alphabets, or some they keep by A, B, C, D, and so on and so forth. But at the end of the day, we teach them how to use hashing to put them in the correct boxes so that they can search in future. We also did something like on the communication protocol. We want them to pair up and then send message. They decide what's the protocol and they're able to send a message across. So those are exploratory. But those are more prescriptive ones are like the sorting algorithms, okay? And also like how you populate binary search tree. How do you traverse? These are more prescriptive, and we want them to get the correct steps. Okay, so we give them the steps and then let them follow through. So I want to use the example of the recursion. Well, most of us know how the recursion codes looks like, and there's nothing much that you can teach beyond that few lines of codes, 4 lines, So we created this activity to help the weaker student to understand how the return or the answer is being withheld until it hits the base case and it bounce back, okay, and finally derive the answer. So the students are seated in the computer labs in columns. So I asked the first student, before that I gave them each one some numbers, a number, and they only know their number. So I asked the first student, what's the sum of your number plus those behind? Okay, and the student say, I don't know. Let me ask the same question to the one behind. So I asked the next student, right? So the second student, the first student asked the second student, what is the sum of your number plus the one behind? Again, the reply is, I don't know. It goes on until the last person, there's nobody behind. The only number that he knows, right? And he report to the one in front. It comes all the way back to me. You can tell me the total. So it is a simple illustration of how this recursion code works in an unplugged activity. And for the weaker student, when they are trying to attempt to solve a problem, a question, and then they forget to call their own function again, we can direct them back to this activity. And remember, you ask the same question, but then now you have one person lesser behind, okay, and they can record it, okay. And then for the teaching of binary search tree, this was done online actually. What happened is that I have the whole name list, but without their date of birth. Okay, I uses only their date and the month. So I get the student to fill it in. This is done on Jamboard. Okay, so the student fill in is a shared document. The student fill in their month and day. And then next, once they're done, they're supposed to drag their name to the correct position, whether it's at the left subtree or the right subtree. Okay, and when they make mistake, okay, the friends will chip in to tell them, okay, and they will argue and say why, that kind of thing. And finally they figure out and they put, and the next person will go on. And finally they populate the binary search tree. Okay, so that was my part 2 for the teaching of BST. And when they've done that, they more or less know how to populate the binary search tree. And I use the tree again in my part 3, where I teach them about traversing. So specifically for the in-order traversing, okay, I gave them a PowerPoint slide. Okay, and this slide is attached to their assignment, and they all have a copy. And what they do is that they will have to do a in order traversing such that the outcome is that they're all sorted from the lowest to the highest. That means those people were born in January, February, all the way up to December. Okay, so if they make a mistake in their traversal, then they realize that the dates don't run. Okay, so this is a PowerPoint slides where they keep and they can play with it anytime they want, anytime they need to recap about this traversal. Okay. Now, I'm sure in lesson, we need to go through the coding with the students, okay? Sometimes, I mean, when I started off, I'm not confident. I will prepare my solution. And then there are times where I don't have, the luxury sometimes of walking through the set, I'll flash the solution, or even I park the solution somewhere and say, download and take a look. We realize that that doesn't help. Okay, we need to help the student with the thinking behind those codes. Okay, and more specifically, it's not the whole solution to the problem itself, but sometimes the core skills. Okay, because solving that problem is only one case. In future, they will come across another question. It may not be the same, but they require certain core skill. So we have to highlight, make those core skills explicit. And we must anticipate because students make very common mistakes. So in our walking through with them, we purposely make those mistakes and run our code, and then show the student how to overcome it, how to debug that, and then get out of that situation. So we do the walking, we do the talking. Students like to code from head to tail, okay? And then when they run into bug number one. They try solve bug number one. Actually, they solved bug number one successfully. They hit into bug number two. Then they thought that their solution for bug number one is wrong. Okay? And then they try to endure, then finally they give up. That's what we see with the weaker students. But if we teach them how to develop their code progressively and test it, then it will be more helpful. Then we also record the videos so that the students can play and replay, okay, and learn at their own pace. We don't give them the solution code. If they want the solution code, they have to watch the video, pause it, and type out the code themselves. And that requires effort. And I think that kind of effort will contribute to their success in their learning. We force them to do something rather than give it to them. Now, sorry, I don't think you can see the code too clearly. It's meant to be that way. But if you give the student codes like this, it's like the blind man's trying to feel around the elephant. Each of them have their own different mental picture, and you really don't know what they know. So, for example, of the linked list, before going through the actual code itself, I will give them a picture. I'll show them the steps. For example, I want to insert a new node in between the previous and this node. So that means before this node. Then what they can do, right, by these two lines of code, they actually link the new node to this node. Okay, so they can see these are the two lines of code that does that. And then this is another line that links the previous code, previous nodes to the new node. So once they have this visual, then they can always go back to this picture if anything go wrong in their code. Okay, so very short sharing. I didn't prepare too much because Mr. Gee told me not to. So yeah, I welcome your questions and interactions. Okay, thanks.
I'd like to feel free to interact with during the break. Yeah. Okay, so these are the students. Yeah. So I asked them an amazing artwork of it. Okay. It's perspective on this so-called seemingly two different subjects, computing and art, and how they actually have certain complementary attributes or concepts that we can try and basically teach the students as community students, community teachers, as well as art. Right. So the time is up.
Okay, so good morning, everyone. My name is Angad Vir, and I'm from Victoria Junior College. So just a short intro about me. I was taking higher art in Victoria School, like he mentioned, and I actually did charcoal, graphic design, 3D modeling, and animation, and video editing. And last year, I was given the opportunity to intern at Think Academy. So I did like 2D animation and some curriculum development also with MOE. And at VJC, now I'm taking physics, further math, and these are my two main favorite subjects. And I feel like now taking computing was a major, you know, opportunity cost I had to consider because computing is actually a very like hot topic, but I really like math also. So yeah. And yeah, I'm in robotics at VJC, and I really like to do 3D printing, robotics, and graphic design. And alongside with that, like outside school, I actually like I'm a iOS developer, so like I develop iOS applications. Yeah. So here are my beliefs and aspirations. So like I believe that with everything we do, like every product we make, uh, there are two main aspects of it. Form and function. And form actually is actually a more artistic term, like form and function, because form is like how it looks, like the aesthetics of the product, and function is the actual the thing which works, like the mechanism, for example. And I feel like both of them are very important. And in art, in computational thinking, even we actually have to prioritize some. You have to actually prioritize form or function in certain scenarios. And in art, I usually like my favorite movements are futurism and minimalism, because futurism is actually a very post World War One thing where the shapes and curves are very like simplistic and very dynamic, and they flow a lot. Yeah. And I'm actually interested in architecture and product design. I'm still discovering myself. Actually, I'm here so that I can, learn more, and maybe like yeah, so that I can shape my thoughts. Yes. So I'll be presenting about my coursework in 2021, which was actually a very unconventional project, because usually people like do traditional forms of art like charcoal or like painting, but I chose to do like 3D modeling on like a software on my laptop, and that software is Blender. So this is just an introduction of my artwork. So like basically um it's actually a modeling of a stadium which I proposed for our school. I mean, it wasn't an actual proposal, but like I just wanted to like you know come up with a possibility that something interesting can happen. So here are just some pictures of the project. So yeah, this is the canteen at the back. So and this is the software I use, which is Blender. So as you can see, the I just wanted to use like symbolism, like the Victoria logo has this torch, which is given like a lot of attention in this whole sculpture. like the 3D torch, where you can actually climb up, just like the Statue of Liberty. So like to give, people like, a sense of pride when they climb up the sculpture. So actually how I combined the form and function was that, for example, the school spirit was shown by the torch, and it actually coupled as a electricity generator, because like I actually designed it such that the rainwater would flow into the middle and like generates electricity, and students can gather at this place to cheer, because in our school there's very limited space for people to like come together and cheer for a match, for example. And so that this can be a hub, like a stadium, canteen, study area, and like like a place for people to like talk to their friends. And along with that, so that uh people can like walk easily between all these spaces, there's like a lot of interconnectivity. So actually, like I mean, part of the computational thinking process was like to research also. So like I researched like good architecture projects, like our Tampines Hub in Singapore. Like really, it's a really good example like how you can merge all these things together and yet still like produce a very nice output. So yeah, there was one more concern, like maximizing land area. So I tried to minimize that with like multiple levels like of the stadium. So let me move on to the more computational thinking aspect of this project. Um, so once I discovered the complex problem, which was this, um, the lack of space and like proper facilities, unique architecture and eco-friendly designs, and also like it's a very hot climate, and we face like the heat of Singapore at that place. Like it's really hot over there, and so I use these four aspects of computational thinking, the DAPA approach. I mean, now in this case, I had structured it because that's how my thinking went: the decomposition, pattern recognition, abstraction, and algorithm design. And this was further, I actually came up with a four-step approach to solve this problem. So the first one was the decomposition. I actually decomposed all these like different parts and identified all these parts which were most worthy of like focus to more realistically revamp the campus, because like it wasn't possible for me to revamp everything. And I mean, this was also abstraction, because abstraction is like simplifying a huge problem into like smaller areas. And yeah, so the next part, which is pattern recognition, is actually the more technical part of this project, where like I had to research on current successful design. Like there's these few examples like the Mercedes-Benz Stadium and National Stadium, where they have these moving roofs to like facilitate all this um, you know multi like more elements to all these like projects which come together to make a product more successful. So the architecture, I actually research on the architectural aspects of a building, like the PSSP approach: political, structural, symbolic, and personal, and the PESTO approach: the political, economic, social, technological, and environmental and legal. So all these uh, aspects were like deeply considered, because I feel like when we are embarking on such a project, it's very important to like focus on all these aspects so that you can uh, even with a smaller space like a school, you can still like adapt a very complicated um, design into a small space. So yeah, I had to research on local and international design and use reverse engineering to like to see how a product is, and then like reverse the process of designing it, and actually like see like all these small things the architects considered when they were making the product. and also contextualize. So like what I mentioned before, all these designs I had to combine it into a small place. So the next part, which is the abstraction, um, actually considered like more like actually it was a very like elaborate process. First, um, this part involved like putting all these parts together. So all these complex ideas from everywhere, I had to, because I work with the teachers, that's why I keep mentioning we. So my teachers, Mr. Heng and Miss Lee, were like a huge part of helping me with this project. So they helped me like come up with all these complex ideas, and I was able to like use their help to like formulate my thoughts properly. And also like I looked into the geometry and pattern based management of these pastel aspects. And lastly, for algorithm design, um, actually this was a repetition of the processes of designing the stadium itself. Actually, it comes in two parts. So the first part is the like how all these seats are very like arranged in a neat manner, like in a very geometric pattern, right? So it was very hard to just do it manually, so I had to use like some blender tools and facilitate this process to make it as geometric and like symmetrical as possible. And I think this is a very algorithmic approach because um it involves like being able to like all your skills, like technical skills, like the Blender skills, to be able to arrange them into one algorithm. So, along with this was a step-by-step approach in incorporating creativity and adapting the architectural concepts. So, I also repeatedly addressed the focus on form and function, and some parts the form was more significant, where other parts the function was more significant. So yeah, this concludes my presentation. And I feel this project was very meaningful towards me because this wasn't um like it wasn't extremely artistic, unlike other people's artworks. And I feel like it was really very technical and very like research based, and involved like a lot of thinking before like actually producing the artwork. Yeah. Any questions?
Thank you so much.
Okay, thank you.
So please feel free to chat with Mr. Angkat during the break. Yeah, or you can also connect to him.
Thank you.
Thank you.
So I think most of you will know him. He's actually he was previously more fantastic, but doing O level, but now he has gone to majority. Yeah. So he's now doing A level complete, right? So yeah. So we managed to have a meeting with the BS art coordinator, and he introduced us to Mr. Angkat because he felt that he has effectively integrated CT into his artwork. Right? So next up, we'll go to the lesson proper.
Yeah, so thank you so much for our speakers that are kind of like appetizers for our session today. So now we get to the main course. So we really wanted this year's CTFest, especially since it's in person, to be hands-on, right? And then the theme that we took was integrating arts. Hence, we what we wanted to share. So let me just introduce myself. So my name is Wendy. I've been a research associate there since 2018, working with Prof. Louis. And so my area of research has been mainly in computing education, which is also my undergraduate degree. And I was a computing teacher in the US and as well as working in research, curriculum development, professional development in the area of computing. All right, so if we just, so for kind of our first interaction, sort of, yeah, okay. So I think it's disconnected because it was connected and it's disconnected. So here, right? And we're kind of recording this. Okay. My screen. One. Okay. Okay. Got it. Click on here. Yep. Okay. Yeah. No problem. Okay. Probably. Okay. I'm good. Okay. Great. All right. Okay. So since it's a hands-on activity, and we really want you to feel comfortable interacting with each other in case you need help or you just want to discuss what you're doing or share something interesting that you're making. So if you can just turn to your neighbors, like whoever you're sitting next to, and share, your name, your school organization, maybe what subjects you teach or your role in the school, and then why are you here? Okay, you're taking a day out of your school holiday. Why are you here? Okay, so please go ahead and take a few minutes to share. Find someone to talk to next to you. Could be behind you. That's fine.
Oh. Oh. Okay.
All right, please wrap up your conversation. Okay, let's let me have your attention, please. I love that you guys really want to talk to each other. You will have opportunity later to continue your conversations. All right, so today I'm going to introduce you to this platform. It's by Carnegie Mellon University, which has one of the best computer science programs in the U.S. Okay, just as NUS and NTU has a really reputable, it's very reputable in this region. So in the U.S., Carnegie Mellon, MIT, Stanford, UC Berkeley are kind of among these top degree programs. So I first heard about this platform at the PyCon Education Summit when two students from Dunman High School shared their experience as teachers for this course. And I think I was really struck by the intent of the designers of this curriculum to teach Python in a non-traditional manner. So we want to share this resource with you, not to necessarily promote this product, even though it is free, right? So, but just to better understand how we need curriculum materials like this in order to attract a more diverse group of students to computing, right? So these are students who may be interested in like something like the arts, right? So this something, something like this might engage their interest. And just like an interesting kind of fun fact is that Jeanette Wing, who you might have heard of, who popularized the term computational thinking, was dean of the computer science department. Okay, so there's an interesting connection there between computational thinking and Carnegie Mellon. Okay. So as you know, right, since many of you teach computing, your students probably write code like, what you see in the upper left corner, right? You type some code and then the output is just text, right? But what you'll see in the CMU interface is there's still code, right? It's still Python, it's still typed out, but now your output is like these graphics, right? So it's graphics based programming, okay? And let's see, so it's worth, again, considering how we can vary our approach to teaching an introductory programming course to get a more diverse group of students interested in computing. All right, so why is the course graphics based? So like what I said before, it could be appealing to a bigger audience, allow students to see creativity in programming. You can debug more easily, perhaps. Okay, that's something you can see if that's true. Errors are visible, sometimes funny, and it's fun. Okay, so and these are things that hopefully you'll experience, or you might want to challenge, or as you are going through the activity. Okay. All right. And here is kind of another reason to think about the kind of positioning, right, of the curriculum. So as you can see on here, these are by grade level, right? So you have primary school to lower sec, which is the first bar, right? So there's the sense of like we're building excitement, right? You have code for fun. There's a lot of enrichment type of activities where students participate in outside of school, inside school. And then you get to upper secondary, right, which is grades 9 and 10. Which still could be fun, right? But it could also start to get kind of dry and, maybe rigorous, and you can kind of see that student enrollment starting to decline, right? Fewer students become interested in it. Although I know that's changing, right? I mean, O-level computing is spreading in schools here. And then you have 11 and 12, which is like your JC. Now this is pretty dry, okay? I mean, at this level, it's like if you're doing computing, you kind of know that you want to do computing, right? This is not for the faint of heart, okay? It's pretty serious stuff. But then again, you have a much smaller group of students, right? Because again, as it's becoming less fun maybe, but more rigorous. And then when you get to university, then it starts to get still challenging, but it's starting to get more exciting and fun again. Okay, because it starts like students start to see a relevance of computing to interesting problems in the world, right? So it's no longer so theoretical or so kind of basic, right? They're starting to see that connection. Okay, so so the idea is that this curriculum is trying to kind of bridge that middle part, still make it to keep students interested and trying to keep that gateway as open as possible. Okay, so I want you to take a look at this picture. These are the student developers and content creators for this platform. Notice the demographics, of like number of, boys and girls, like different races. I mean, this is the US, right? So, and I really hope that we want our university computing student demographics, as well as in your classrooms, to look more like this, okay? I think that we need a more diverse computing workforce with people from different backgrounds and interests, like arts, right? Like architecture, right? We need students like that with these interests, and not just be so narrowly focused on doing computing, right? But we need humanities students, right? We need all kinds of students with different interests, different backgrounds, from different communities to be part of this computing field. And we need more than token like representation, right? Just because you have a few girls in your classroom and they're awesome, they're great, okay? They're really good, but that's not enough to really change the field. Okay, so that's why it's important that we have a critical mass. There's no innate biological reason for unequal participation. Okay, these barriers can be overcome. And I know Mr. Rizwan told me that he actually has a class, computing class, where where there's balance, right, of gender. So we need to study, right, classrooms like that to better understand, why is it that there are classrooms like that? What are the conditions that make that possible? Okay, and since programming is such a key gatekeeper to like further studies, this is a really important part, right? We do need kids to know programming, because if they succeed at this will take them to the next level. Okay. All right, so let's go on. Just a refresher on computational thinking. So this is a word cloud from a 2016 study of the existing literature on what scholars and have written about computational thinking. And these are the words that that came out most often, right? Most frequent. So you probably recognize many of them. All right, and then the important thing to note is that this isn't about learning a particular programming language, but it's about learning how to think in certain ways, okay? That's applicable in programming, in computing, but also in other areas. Okay, so let me just give you a quick example of how this works with programming. It's not the only way to learn CT, but it's a very natural fit. So this is from this programming game called Lightbot. Some of you might have seen this. It's for young kids, right? There's all the commands are in graphical form, so you don't even need to know how to read. But the goal of this series of puzzles is to light up all the blue squares. And so here you see computational thinking skills like problem solving, algorithmic thinking. You see like a pattern, right, that's being repeated. Here you can create a procedure or a function as an abstraction. There's even recursion, okay? So you have the procedure actually calling itself. And the robot is smart enough to not get into infinite loop. So it'll stop as soon as all the squares are lit up, okay? And so as the puzzles get more challenging, students have to consider how to use multiple procedures, how to make their programs efficient, because now there's a limited amount of space for commands, right? You notice there's only a certain number of boxes, and then how to decompose complex patterns into several basic sets of patterns, okay? So as you're working through today's intro programming module, I want you to think about what kinds of computational thinking skills are you using, okay? Think about the algorithmic thinking process, the abstraction, the patterns, decomposition, right, and debugging, right? So there are many kinds of computational thinking. And also just to put the activity in context, right, for today. So this is actually the Academy's full offering. So you'll see that there is CS0, CS1, there's advanced placement, that's what AP is. There is CS2, and then all the way up to sort of college level, okay? Now, what we're gonna do today is called an hour of code. And so it starts at the CS0 level, okay? So that just to give you an idea, a taste of the curriculum. So this module requires no prior programming knowledge, and you can work at your own pace. So again, I know some of you are like super advanced, at Python, so you'll kind of get through this, but we don't want to assume that our audience is at that level. So so really you can assume that there's no prior programming needed. All right, so now let's get to it. So in order to sign into this, you want to go to this website, academy.cs.cmu.edu. By the way, if you've been sitting there for a while, you may have noticed that you've disconnected from the guest Wi-Fi. All you have to do is disconnect and reconnect, okay? And then it'll kind of pop up a new web page, and then you'll be reconnected again, all right? So that's the website. There is a login button on the upper right corner of the page, and then you're going to get your login information from this Google Doc. Okay, it's tinyurl.com/ CTFest 2022 HOC. HOC stands for Hour of Code. Okay. And like I said, I've created accounts for you, so that will save us some time for you, so you don't have to register for an account. Okay, so I'll leave that up for a bit. I'm just gonna switch very quickly, okay, just to show you. Like, this is these are what basically your name, your username, your password. If your name is not on here, like let me know, and then I can. There's some extra accounts, student accounts, okay. So raise your hand if your name isn't down there, and then I can assign you a student account. Okay, so yeah, raise your hand if you don't see your name.
The words are too small.
Sorry, for which one?
Can you show the list again?
Oh, it's at tinyurl.com/ctfest2022 HOC. So if you go to that website, it'll take you to this one. Okay. Yeah. So go to that Google Doc. You'll see the full list of the student the login information. Yeah, and let me know if you need any help. we have people around who can help you get logged in if you need to. And of course, you're sitting next to people that you have met. You've introduced yourself, so you can also turn to your neighbor and ask for help. Okay. Is anyone not logged in? Is everyone? No? Okay, yeah, that's fine. That's fine. Just let me know so I can, yeah, thanks. Yeah, because I want to know when I can move on to show you, to demo the platform. Okay, so does anyone else need help logging in? Because if not, I'm going to just quickly show you what your goal is for today. Okay, where am I? Okay, no, that's not it. I need the hour of code. Yes, there it is. Hour of code. Okay. Oops, that's not it either. There we go. Okay, so you should see something like this. This is actually the teacher version. So you're not going to see some of the stuff that says teacher portal and things like that, okay? But you should see this, okay? It should look something like, is this right? No, that's not right. Hang on, hour of code. Okay, here it is. This is what you should look like, okay? So today's hour of code just has 1.1, 1.2, and 1.3, okay? And so you're going to work through each of these. So there's some videos that will kind of explain, what you're doing. And then you can, you click on these things in order to make to run the code. There are some checkpoints along the way, and you can keep track of your progress on the left side, okay? And also there's these things called examples. You can take a look at them, but if you don't, you can try some of these, but there isn't, that they're pretty open-ended. Okay, so so you can just spend as much time as you want on them, but then just move on. Okay, so you don't have to spend too much time on them. Okay. One more thing before I release you to do your thing. So at the end, later on, we're gonna have a debrief, okay? So I want you to keep this in mind as you're working through the hour of code. So I want you to reflect on what was your experience as a learner? How did you use computational thinking? What do you think about using this approach, this graphics-based approach for a beginner to learn programming? So kind of putting your, like putting yourself in the mind of a student who might be learning programming for the first time, right? What do you think their experience be like? And then how might you use this in your school or organization? Okay, so those are three debrief questions later. So keep those in mind as you're working through the hour of code. All right, any questions before we begin? Or before you begin? I'm done. It's your turn. Okay. All right, so go ahead. Okay, get started. If you need any help or have any questions, you may turn to your neighbor or raise your hand, and one of our friendly facilitators will come to you.